Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 4, Section 3, Greatest Common Factor. So the first thing we want to talk about is really what is greatest common factor. Greatest common factor is the biggest number that will divide into two or more numbers. So for example, with the numbers 12 and 18, the biggest number that will go into both 12 and 18 is 6. 6 will go into 12 twice, and will go into 18 3 times. Now, in elementary school, and oftentimes in middle or high school, you were taught to find GCF by listing out all of the factors of both of the numbers and trying to find which one is the biggest one that they share. I'm going to teach you today how to find GCF using what we learned in Chapter 4, Section 2, which is the prime factorization of the numbers. And if you're my student, then you need to make sure you pay attention to this and take notes on it, because this is how I expect you to find GCF, and this is the work I expect to see when you are finding GCF of two or more numbers. So what we're going to do first, though, is we're going to take a look at what is the significance of the prime factorization of a number. What does it do for us? And then we're going to talk about how that helps us find GCF. So for example, if I take the GCF, if I take the prime factorization of 54, we can do 6 times 9, 3 times 3, and 2 times 3. So what we have here for a prime factorization is 2 times 3 times 3 times 3. So what's the significance of that? How is prime factorization even important at all? Well, one of the important things to know about prime factorization is that every number has one. Every number can be made up of prime numbers. Now, there is something else, and this is really, really important, we can do with prime factorization. What we can do with this is we can come up with every single number that goes into 54. So using just these numbers here, I can come up with all of the factors of 54. So the prime factors of a number will allow me to find all of the factors of that number. So when I take the prime factorization of 54, I can find all the factors of 54. So how do I do that? Well, first of all, we know 2 and 3 must go into it. So we have 2 goes into it and 3 goes into it. 2 times 3 is 6. 3 times 3 is 9. 3 times 3 times 3 is 27. And of course 1 goes into every number. And there are no other combinations of numbers here that I can multiply together. So here are all the factors of 54. So essentially all you do to find the factors of a number with the prime factorization is you multiply all the different combinations of numbers that you have. So how is that important? How is that helpful in finding the greatest common factor of two numbers? Well, let's take a look at two numbers and find out. If we take the number, let's go with 54, and we'll go with 36. We'll break those down. So the prime factorization of 36 is 2 squared times 3 squared. So what I did there, where the exponents came from, is the prime factorization of 36 is really 2 times 3 times 2 times 3. So 2 times 2 is 2 squared, and 3 times 3 is 3 squared. They're the same thing. So I just kind of simplified it. Instead of writing all 4 numbers out, I can simplify it, make it a little bit shorter. And what that also does is, instead of having 2 2's for this number written out and 1 2 for the 54 written out, all my 2's are going to be in one column. So for example, when I go to write 54's prime factorization, I'll put 2 right here underneath that one, And then there are 3 3's in the prime factorization of 54, so we're going to go times 3 to the third for 3 3's. And what you're going to see is we're multiplying 2 3's in 36, and we're multiplying 3 3's in 54. We're multiplying 2 2's in 36, and 1 2 in 54. Now that's important because if you remember earlier, we said that with the prime factorization, you can find all of the factors of a number. So if the prime factorization of a number can find us all of its factors, then the common prime factors of 2 numbers should get us all the common factors of those 2 numbers. So I'm going to say that one more time, just to make sure we understand that. If I can find all of the factors of a number using its prime factors, then that means I can find all of the common factors of 2 numbers using those 2 numbers' common prime factors. Okay, now say that one more time, just a third time, just to make sure. The prime factors of a number can get you all of its factors, so the common prime factors of these 2 numbers should be to get me all their common factors. So the common prime factors that 54 and 36 have, you can take a look here. We're multiplying 2 3's, we're multiplying 3 3's. So the common factors would be the 2 3's. Okay, each of them have 2 3's and at least 2 3's in them. And then over here with the 2's, they both share a 2. Both of them have at least 1 2 in their prime factorization. So if we take that, we take 3 times 2, or I could write 3 squared. These are the common prime factors of 36 and 54. So since the prime factors can get us all of the regular factors of these numbers, their common prime factors should be able to get us their common factors. So let's take a look. 2 goes into both of them. They're both even. 2 goes into them. 3 goes into both of them. 3 goes into 54, and 3 goes into 36. 3 goes into 36 12 times. And 3 goes into 54 18 times. 3 times 3 is 9, so 9 goes into both of these numbers. 9 times 4 is 36, and 9 times 6 is 54. 2 times 3 is 6. 6 times 6 is 36, and 6 times 9 is 54. And then if we multiply all of them together, that's going to get us the GCF. Because obviously if I multiply all these together, that would be bigger than multiplying 1 or 2 of them together. So 3 times 3 is 9, times 2 is 18. So there's my GCF of these 2 numbers. 18 goes into 36 twice and into 54 3 times. So using the prime factorization of both numbers, I found their common prime factors, multiplied those common prime factors together, and that got me the greatest common factor, or the biggest factor that these 2 numbers have in common. So the short of it is, if you want to find GCF using prime factorization, you're going to factor tree both numbers, write their prime factorizations out, find the prime factors they have in common, like we did here, and then multiply those prime factors together. So the 3 times 3 times 2, which gets us 18, and that'll be your GCF. And if you aren't 100% clear on why this works, and you still and you want to know that, please ask a question in class and get a hold of me. Let me know. Real quick, I want to add something to this. We now know how to find GCF of 2 numbers, but something else you're also going to be asked to do is to find the GCF of 2 monomials. So you might see something like a cubed b and a squared c. Okay, so you may have some variables on the end of these numbers. So when you're writing out the prime factorization, so for example, when we write out 54's prime factorization, we would write 2 times 3 cubed times a cubed times b. Okay, so we're going to include those letters into the prime factorization. So the process here doesn't really change a lot. If I want to find the GCF of these two monomials, the process doesn't change a whole lot. You just need to remember to add the letters onto the end of the prime factorization. So now I'm going to write out 36 as prime factorization. So here's 2 squared times 3 squared times a squared times c. Okay. So again, we're going to take a look and we're going to see what do they have in common. We're going to look at the 2's. There's 2 2's being multiplied and 1 2. So they have 1 2 in common. There's at least 1 2 in each of their prime factorizations. Take a look at the 3's. There's 2 3's here. There's 3 3's here, so they share 2 3's. Going to take a look at the A's because they have A's in common. So there's 3 A's here. There's 2 A's here. So we're going to go with the 2 A's. Always take the smallest because I can't have 3 A's in a prime factorization. It only has 2. You take the smallest one because that's the most. If 2 is the smallest one out of the 2 and the 3, 2 is the smallest. So each of these has at least 2 A's in common. Is kind of the way you would think of it. This one can't have 3 A's in common with this one because this one only has 2. And then down here on the end, we're going to take a look. We have a B and a C, but the prime factorization of 36 down here does not have a B in it, so we're not going to include that in our GCF. And the prime factorization of 54 does not have a C in it, so we're not going to include that in the GCF. So if we don't have a B in both of them, we ignore it. So, for example, now what we would do is we would again take all of the common prime factors and multiply them together. So I'm going to do 2 times 3 squared times a squared, because those are all the common prime factors. And the 2 times 3 squared will get me 18 again. And the a squared, there's nothing to multiply it by, so we leave it as is. And to write 18 times a squared, you would just say 18a squared, and there's your GCF. So if you're doing it with monomials, this is how you would do it. Same process, find the prime factorization of each number. Okay, make sure to include the variables on the end this time. Find not only the common prime factors they have, but also the common variables that they have. And you will then take all the common prime factors and variables and multiply them together. And in this case, we got 18a squared. So, and again, if there is something in the top row that you don't see, such as if there was a 7 up here, but there's not one down here, then you don't include the 7 in the GCF. Or, as in this case, there's no b on bottom, but there is on top, so we don't include the b as one of the common factors. One of the common prime factors, I should say. So that's really all there is to greatest common factor. One thing I would note is if you have 3 numbers or 3 monomials, you would write out 3 prime factorizations and find what all 3 of them have in common. So it's the same process, you would just have another row. And the same thing if you had 4 numbers you're finding GCF of, you would have 4 rows of prime factorization that you would be trying to find what they have in common. So that's it on GCF. The next section is Chapter 4, Section 4, Simplifying Algebraic Fractions, which will actually be using this GCF and prime factorization stuff in as well. So tune in for that video.